now if we reject the null hypothesis in the original ANOVA test, okay, ANOVA test is all the means are equal, not all the means are equal as the null and the alternative. So if we reject the null hypothesis that not all of them are equal, then a question arises, then which of those means is actually different? Okay, at the end of the ANOVA test, all we are saying is that not all the means are equal. So that opens up a second set of questions. Okay, which pair of means is actually different? And so the post rejection analysis is required to further determine which means are different, and for that we use what is called the Tukey-Kramer procedure. There are several procedures available for comparing or further analyzing the results that we have already obtained. So what we will do here is we will take each pair. So you have 3 means, then we pair 1 and 2, 1 and 3, and 2 and 3. So there are 3 pairs that we can derive from 3 means, and then see which of those pairs is actually different. So if you have 4 means, then you will end up with 6 pairs. Okay, 1 with 2, 1 with 3, 1 with 4, so that's 3, and then 2 with 3, 2 with 4, that's 2 more, so that's 5, and then 3 with 4. So there are 6 pairs if the number of means that we are testing is 4. So then we can then go and see which of those pairs is actually contributing to saying that not all means are equal. So that procedure that we are going to look at is Tukey-Kramer procedure, and for that we compute what is called a critical range. The critical range is computed with this formula. Now this Q sub A is an upper tail critical value, and it comes from a table. We have to use the table given in the back of the textbook for this. And then the mean square within, or the MSE, mean square error, in the analysis of variance table, which is, this is your denominator variance. So MSW over 2 times the sample sizes here are for the particular pair we are testing. Okay. Now that will give you the critical range. So if the difference in the x bars for that pair, so here if it is j and j prime, you look at the mean for sample j and sample j prime, take the absolute value of the sample mean difference, then if that difference is greater than the critical range, then that pair is different. So that is contributing to our rejection of the null hypothesis. So if all the sample sizes are the same, then this critical range will be the same for all the pairs. But if the sample sizes are not all the same, then we have to compute critical range for each of them separately. So here is the example with 3 means. So we have 3 pairs, okay, and the absolute difference in the sample means are these. Then you get the Q sub A value from appendix E.7. Okay, C equal to 3, n minus C equal to 12 are the 2 degrees of freedoms. And then with this Q sub alpha, you compute the critical range, and you compare that critical range with the actual difference, the absolute value of the difference, and as you see, all the pairs have differences that exceed the critical range. So all of them are different. So let's look at an Excel example next.